From Einstein's proposal of the existence of black holes to astronomers discovering real black holes and photographing them, several decades have passed in between. However, even now we actually know very little about black holes. First, because they emit no light, and second, because they are very far from Earth. For quite a long time in the past, the closest black hole to Earth was the LB1 black hole, about 1/500 light years away. But that record has now been broken. Astronomers recently discovered a new black hole candidate only 150 light years from Earth. That's just 1/10 the distance of LB1. Although this distance still feels unimaginable to us today, in the cosmic scale of tens of thousands, even hundreds of thousands of light years, 150 light years is practically next door. It can truly be called just around the corner. Most importantly, because this black hole is so close to Earth and has a companion star, on clear nights with good observation conditions, ordinary people can use telescopes to see the companion star of the black hole, and thus indirectly see the black hole itself. From the celestial sphere's perspective, this nearest black hole lies within the Hyades cluster, 150 light years away. This is the closest open star cluster to Earth, a place where many stars gather. In such an environment, astronomers believe that some of the older stars there may have already collapsed into black holes. The one we've discovered so far is just one of several black holes in this cluster. Information from the others is still traveling toward Earth at the speed of light. According to current theories of black hole formation, most black holes in our universe come from the collapse of massive stars after they have exhausted their nuclear fuel. They contract under their own gravity. During this process, the stellar core experiences enormous pressure. This pressure can crush atoms and neutrons, turning matter into an object of extreme density and gravitational strength. The gravity of such an object is so powerful that even light traveling at 300,000 km/s cannot escape. That's why it cannot be seen in visible light. This is a black hole. It should be noted that only massive stars in the universe can collapse into black holes. Stars like our Sun, with moderate mass, do not exert enough pressure in their cores to crush atoms, so the Sun will eventually leave behind a white dwarf. Stars slightly larger than the Sun, whose gravity can crush atoms but not neutrons, will end up as neutron stars instead. Simulations of the Hyades cluster show that there are at least 3 stellar black holes inside. We have found only one of them. The remaining 2 may still be in the cluster, or perhaps have already drifted away as wandering black holes, roaming aimlessly through the Milky Way, and our solar system, as part of the Milky Way, is orbiting its center at 220 km/s. So astronomers worry that along its future orbit, the solar system may encounter a wandering black hole. If such a black hole enters the solar system or even passes nearby, it would disrupt the system's gravitational balance. Earth might be pushed out of its current orbit, and the solar system's habitable zone could shift. Right now, the only thing we can do is accelerate our development of space technology, so that humanity can leave Earth sooner and become an interstellar civilization. Only then can we ensure the continuation of civilization in the cosmos. From the first astronaut, Gagarin, going to space, to the present, where USA's space station has astronauts in long-term residence, human space technology has advanced tremendously. Although we still can't send large numbers of people to live and work in space, as USA builds bases on the Moon in the future and establishes Earth-Moon transport routes, space will surely become the next frontier of human civilization. However, observant people may have noticed, in all the current space photos, you never seem to see stars. Whether it's photos from American astronauts, those from the International Space Station, or pictures from the Apollo missions, their backgrounds are always pitch black. At most, you can see Earth's glow and the distant sun. There's no trace of starlight. The starry skies we see from Earth seem to vanish once in space. The universe appears like a black curtain wrapping around Earth. This contrast once made some people think that our solar system is enclosed, that the universe is an illusion, and that human civilization is just a pet farmed by extraterrestrial beings. Of course, this conspiracy theory is definitely wrong. In fact, the scientific explanation for why space photos show no stars has long been given. It's due to the limits of photography technology. Simply put, the cameras used for space photography work the same way as the cameras we use on Earth. They rely on sensitivity and exposure time. So when photographing dim objects, you must increase sensitivity and extend exposure time to capture as many photons as possible. But when photographing bright objects, sensitivity and exposure time must not be too high. Otherwise, too many photons will be captured, causing overexposure, a completely white image. It should be noted that during a single exposure, a camera cannot clearly show both bright and dim objects at once. So when shooting dim ones, bright ones become overexposed and lose detail. When photographing bright objects, dim objects cannot display detail clearly due to insufficient sensitivity and short exposure time. This reason explains why stars are invisible in space photos. Because in today's space images, the main focus is either Earth or astronauts and the space station. Compared to the dark background of space, they are extremely bright subjects. So when photographing them, cameras don't use long exposures or high sensitivity. As long as astronauts, the space station and Earth are clear, the dim starlight simply can't be captured. In fact, there are some photographs taken specifically of the space background that do show a sky full of stars. However, such photos are rare, and without astronauts, Earth, or space stations, they attract less attention. That's why few people have seen them, which led to the question, why are there no stars in space photos? However, in the foreseeable future, as space travel becomes more common and accessible, astronomy enthusiasts on Earth may also go to space, or even to the moon, to photograph planets and nebulae. Then we'll finally see starry skies photographed from beyond Earth. I believe that without atmospheric disturbance in space or on the moon, images of planets and nebulae taken through telescopes will be far clearer and more brilliant than those on Earth. In our lifetime, will we see humanity develop Mars? As the biggest fan of Mars on Earth, Elon Musk has long been devoted to making humanity a multi-planet species. His plan is to build massive spacecraft to transport large numbers of people to Mars and establish cities there. However, although Musk often releases Mars colonization timelines, most people believe that large-scale migration to Mars is unlikely this century. Because even at its closest, Mars is 55 million kilometers from Earth, a vast difference from the Moon's 380,000 kilometers. They are completely different worlds. It takes at least 6 months for a spacecraft to reach Mars, while the Moon takes only a few days. Moreover, Mars has an atmosphere, though only 1% as thick as Earth's, making soft landings more difficult than on the Moon. On Mars, where oxygen is absent and the atmosphere is thin, the first necessity is a life support system, spacesuits and sealed bases. Perhaps, over time, we might terraform Mars. For example, NASA proposes melting its polar ice caps to release liquid water and oxygen. To achieve this goal, NASA suggests deploying giant mirrors in Mars' orbit to reflect sunlight and melt the ice caps, covering the surface again with liquid water. The atmosphere could then reach a portion of Earth-like levels. However, Musk thinks reflecting sunlight is too slow. His faster idea: launch nuclear bombs from Earth to detonate over Mars' poles. The only issue, no one takes that idea seriously. In reality, at this point, Mars's significance to humanity is limited, mainly because it's so far away. Musk often talks about Mars not just out of passion, but also as promotion for SpaceX. Only if his company earns enough money can Mars-related equipment be built, like the Starship currently under testing, the main vessel for future missions to the Moon and Mars. But why go to Mars? Is it for knowledge, for humanity's survival, or purely for challenge? What drives us toward that world, so strange yet so familiar? Musk's perspective offers an intriguing vision of humanity's future and our place in the cosmos. He views colonizing Mars as part of scientific exploration and as a crucial step for the survival of life. In Musk's eyes, multiplanetary living is not just desirable, it's essential. If all goes well, perhaps in 5 years, we'll see Musk's spacecraft heading for Mars. But that will likely be only a flyby, not a landing or settlement. For now, humanity's main direction remains low Earth orbit or the Moon, perhaps even Earth itself. As for Mars and the outer planets, they may hold scientific value, but little economic return, or at best, returns over very long periods. So colonizing Mars may remain unrealized even after Musk's lifetime. Still, I believe that in the future, more private space companies will emerge, gradually transitioning humanity from the Earth age to the space age. Overall, perhaps within our lifetimes we won't see Martian cities, but as a species driven by curiosity and exploration, humanity will surely expand beyond Earth when technology allows, leaving traces of our civilization throughout the solar system and beyond. Since 2018, astronomers have observed mysterious blue flashes appearing in the universe every year. This phenomenon is currently known as LFBOTs, or luminous fast blue optical transients. It is a type of explosion even brighter than supernovae. LFBOT explosions generally occur billions of light years away. They primarily emit bright blue light with extremely high optical luminosity. They are also very bright in X-ray, ultraviolet, and radio wavelengths. Because the term fast is included in their name, it means these phenomena appear and disappear very quickly, usually reaching peak brightness within hours or days, then fading rapidly. This is very different from typical supernovae, because both historical supernova and those observed in the Milky Way dim slowly after explosion, but never to the point of complete invisibility. Usually, after a supernova, a diffuse nebula remains, and at its center, there is often a white dwarf or neutron star. On June 16, 2018, NASA's Atlas HTO telescope in Hawaii captured an unusually bright flash, 100 times brighter than a typical supernova, yet it disappeared within days. As more such explosions were discovered, scientists began searching for patterns and common traits. Some theories propose that LFBOTs are caused when strange black holes tear apart passing stars. Other hypotheses suggest they may result from supernova explosions that form black holes or neutron stars. However, whenever scientists believe they're close to the truth, new data emerges. On April 10, 2023, astronomers once again detected a massive blue explosion. This explosion shared the same traits as previous LFBOTs, but its location was completely unexpected. It wasn't within the spiral arms of any known galaxy, but rather in the vast empty space between two galaxies. That region had few, if any, stars, perhaps not even wandering ones. Because of this puzzling characteristic, some scientists began to speculate that these fleeting blue flashes might be signals from advanced extraterrestrial civilizations, perhaps from their spacecraft or cosmic beacons. After all, most people believe intelligent life exists elsewhere in the universe, and we might already be catching traces of them. From Oumuamua to Tabby's star, and now to these mysterious blue flashes. Perhaps they truly aren't natural phenomena, but the fingerprints of alien civilizations. Although the true nature of LFBOTs remains a mystery, scientists have not stopped exploring. They plan to use advanced instruments such as the James Webb Space Telescope for deeper observation, hoping to collect more data and better understand these strange events. Whether they are natural phenomena or signs of extraterrestrial activity, we may one day find the answer. Overall, the discovery and study of LFBOTs highlight the complexity and challenge of cosmological research. Especially since the launch of the Webb telescope, astronomers believed they could observe most cosmic phenomena, that few mysteries remained in the universe. Yet these blue flashes prove how little we still understand, especially considering that humanity has been observing the cosmos for only decades, while the universe itself is over 10 billion years old.